Hello everyone, I'm Dasari Abhijith Reddy from Engineering Physics 3rd year IIT Roorkee. Today I'm going to give a presentation on tilt sensors. In this presentation we are going to cover what tilt sensors are, the working principle involved, the circuit of a tilt sensor, the types of tilt sensors used, the applications of them, the specification of a tilt sensor that we would like to use, the benefits of using a tilt sensor. Last but not least, we are going to see the future developments in tilt sensor technology. So what are tilt sensors? Tilt sensors are devices that measure the orientation or angle of an object with respect to the Earth's gravity. They are used to detect and measure the tilting, tipping or inclination of an object or surface relative to a horizontal reference plane. Tilt sensors produce an electrical signal that varies with angular movement. So these are also used to measure the slope and tilt, but they have a limited range of motion. Coming to the working principle of a tilt sensor, a typical tilt sensor consists of a rolling ball with a conducting plate beneath it. When the sensor is given power across its terminals, the rolling ball falls and makes an electric connection and hence makes the circuit active. But when it is tilted, the ball acts like an open circuit and it doesn't let current pass through the terminals. As we can see here, the tilt sensor is connected in a circuit with a resistor, a battery and an LED. When it is powered on, the rolling ball settles at an upright position and hence we have an electrical connection between the two ends of the sensor. Due to this, the LED gets sufficient current and hence it glows. But when the sensor is tilted, the rolling ball doesn't settle at the bottom of the sensor and the circuit becomes open, and in this case the LED doesn't glow. There are four types of tilt sensors. First we are going to discuss about the force balance sensor. These sensors are gravity reference sensors and these are used for DC acceleration measurements for objects like ships, vehicles, aircrafts and even for seismic events. Some of their advantages are they have a high accuracy, they have a change in broad measurement, they are insensitive to temperature change. But one of their disadvantages is their high cost. Next we have MEMS sensor, where MEMS stands for micro electromechanical systems. These solid-state MEMS are small sensors as they consist of movable proof mass plates that are attached to a reference frame through a mechanical suspension system. This is a technique of combining mechanical and electrical components together on a chip to generate a system of miniature dimensions. Now the dimensions of MEMS are at par of a human hair strand. I mean, imagine how small it is. So MEMS sensors are key components in medical industry, in aerospace industry, the consumer industry and the automobile industry. And due to their small size, they are used in smartphones, in gaming, medical tests as well as in satellites. Next up we have the electrolytic sensor. The electrolytic sensor is used to measure angles and the angle may be expressed in degrees, arc minutes or arc seconds. Electrolytic sensors produce extremely accurate pitch measurements in many applications. These sensors easily maintain their high accuracy and have a small size. They function by using cavity filled with a fluid or a glass. The fluid performs between a common positive and negative electrode. When the electrolytic sensor is leveled, both the positive and negative electrodes get consistently submerged within the fluid and hence produce a balanced signal output. But when the sensor is rotated, an imbalance is created between the two electrodes. So the imbalance of any one of the electrodes is proportional to the angle of rotation as seen in the figure. Lastly, we have capacitive tilt sensors, which are designed to take non-contact measurements of inclination and tilt. They can be operated both as switches and sensors, yet the capacitive sensing is independent of the base material that is used. These devices consists of suspension beams, comb drive capacitors, and central proof mass. When tilt occurs, the central mass moves towards one of the combs, so the capacitance increases at one side and decreases at the other side. The main advantage of capacitive sensor is its performance ratio and cost effectiveness, whereas one of the main disadvantages of it is the limited response given by it. There are a lot of applications of tilt sensors in our daily lives. It is used in construction and mining equipment, where in heavy machinery such as bulldozers, excavators, and mining trucks, we use it to monitor the slope and inclination of the machine. And this allows the operator to adjust and stabilize the equipment, making it safer to use and reducing the risk of accidents. It is used in gaming devices like joysticks, which allows the player to control the movement of the game character or object by tilting the device in different directions, and hence giving the expected immersive and interacting gaming experience. It is used in aerospace engineering and in automobiles too. It is used to control the aircraft's altitude by measuring them and allowing pilots and flight controllers to make adjustments as needed. It is used in automobiles to monitor the vehicle's pitch and roll angles, and hence using this, the car's traction and braking systems are adjusted to have a safe travel. Tilt sensors are also used in solar panels, where we monitor the angle of the panel with respect to the sun, and hence we adjust the angle in such a way that we get the maximum intensity of light for the maximum energy output. Robotics uses tilt sensors a lot, and tilt sensors are like an essential part of the robotics industry. Uh, it is used to control the movement of the robot, allowing it to maintain its balance, move smoothly and accurately, and perform specific tasks, like you can see in the robotic hand here. It is used in medical devices such as the tilt tables, the tilt sensors, to measure the angle of inclination. These sensors also allow the doctors to monitor a patient's response to various treatments and make the necessary adjustments. Different types of sensors have different specifications to make them suitable for different applications. Now, when we are selecting a particular tilt sensor, we have to consider the following specifications: the number of axes, the tilt sensor's resolution, its sensitivity, measuring range, its noise tolerance, and last but not least, its resistance to vibrations. Coming to the benefits of the tilt sensor, it is compact and simple to use. It has a high resolution and is accurate. It is very much cost effective. It uses low power to work. It is easy to operate and it is highly reliable. Just like every other sensor, the tilt sensor also has a scope for improvement. Some of its possibilities are: it can have a higher accuracy, it can be integrated with other sensors, it can be connected wirelessly, it can have the feature of self-calibration, and it can also be made into a more compact sensor, like reducing its size so that it can be handy and it can be used in many other applications too. Here is a list of references that I have used to prepare the presentation. Thank you for listening.